Hi, and welcome to this short context bite describing some of James Joule's early work and his scientific results which led to the conservation of energy law, and contribute to some of the definitions of the first law of thermodynamics. James Joule owned a brewery, and he wanted to automate it with either steam power or the newfangled electricity. As such, he conducted a number of experiments in order to see which method was more efficient, but he needed something to standardise the results of these experiments. He used the idea of friction heating water and the temperature rise being measurable. A weight was dropped through a height which turned a paddle in a known quantity of water. The bigger the weight that fell, or the bigger the height it fell through, the bigger the temperature rise of the water. Work is done on the weight by raising it in a gravitational field, and as that weight falls, it can do work on the water. This is an example of mechanical work. Mechanical work is done by applying a force and moving it over a distance, or as Newton said, work done is force times distance. Joules had noticed that energy is just a system's ability to do work, by which I mean thermodynamic work. High energy systems can do more work than low energy systems. If work is done on a system, the internal energy increases and that system has a greater ability to do work. All work is just the equivalent of raising a mass in a gravitational field. If we do work on a system, the internal energy of that system increases because it now has a greater ability to do work. If we allow a system to do work on the surroundings, the system's internal energy decreases because the ability of the system to do work decreases. Joule was the first person to quantify a system's ability to do work. This is why the unit of energy is named Joule. Further in his experiments, Joule had given us the idea of a thermodynamic state function, that being the same amount of work, no matter how it was performed, brings about the same amount of change in a system. State functions are important in thermodynamics, and you will see them used widely in this course. I hope that this video has been interesting and has given some context to the history of our understanding of work and energy. As always, if you have any questions, please do not hesitate to contact me. I look forward to seeing you in other videos.